Hello coders, welcome to my channel. I am Aniket and today we will discuss problem 3558 from LeetCode, that is number of ways to assign edge weights first. Let's read the problem. There is an undirected tree with n nodes labeled from 1 to n rooted at node 1. The tree is represented by a 2D integer array edges of length n minus 1. So the edges length is n minus 1. So you can easily find what is the number of total nodes. Simply edges dot length plus 1, where edges I denotes ui to vi edge and indicates that there is an edge between nodes ui and vi. Initially, all edges have a weight of 0. You must assign each edge a weight of either 1 or 2. Okay. The cost of a path between any two nodes u and v is the total weight of all edges in the path connecting them. Select any one node x at the maximum depth. At the maximum depth, return the number of ways to assign edge weights in the path from 1 to x such that its total cost is odd. We want our total cost to be odd after assigning each edges to 1 or 2. And since the answer may be large, return it modulo 10 raised to the power 9 plus 7, because you want to find the number of ways to get the cost odd, so the answer can be very large. So that's why the question specifies that you have to mod it by 10 raised to the power 9 plus 7 to get in the range of int. Ignore all edge node, ignore all edges not in the path from 1 to x. So the 1 is denoting the root and x is denoting the node present at the maximum depth. So first question arises that how can we find how can we find the x which is at the maximum depth. So what is the answer to this question? Our objective is finding the number of edges between 1 to maximum depth node. So we want to find number of edges between 1 to x. So there is no significance of value of x. Value of x is not, it doesn't matter to us. Let's say the x will present at this place and you perform several edges to reach this x. So how many edges present between 1 to x node? So it is 1, 2, 3, 4. So how can you find the number of edges? Now the question becomes, how can we find the number of edges between root node to the maximum depth node? So we can use simply BFS traversal, level wise BFS traversal, to find the number of edges between 1 to the deepest node. So we can use BFS, or you can say level order traversal, to find the number of edges. So let's say this level is 0, so and this level is 1, this level is 2, this level is 3, and this level is 4. So the level at the last index, the last node which is at the deepest value, so it is the level is 4. So the number of edges between 1 to the deepest node is simply 4. What is the observation? The number of edges between 1 to deepest node is simply equal to level of that node. So in this way you can easily find the level of that node using BFS level order traversal. And now the next question becomes, how can you find the number of ways to place 1 and 2 such that the total sum becomes odd? So now the next question becomes, how can you find the number of ways to assign 1 or 2 to the edges such that the sum becomes odd? So how can you find it? Let's say after doing BFS level order traversal, you find level as capital A. The number of level is something, number of edges is capital A. Now you go to 1 to capital A, that is number of edges, and assign each value to 1 or 2. So there are two choices for each edge. There are two choices for each edge. So first choice is assign 1 to it, or second choice is assign 2 to it. This is the classic pattern of a DP. So we can use DP. We can use DP in this question to find the number of ways such that our total sum is odd. Let's make the DP tree diagram. The first node will be A, which is denoting the edge number, and the second node will be sum. So first node is edge number, and the second parameter is sum. So at this place we have two choices. If we go to plus 1 or we go to plus 2. If we go to plus 1, now the number of edges become a minus 1 for placement, and now the sum becomes 1. In this case number of edges also becomes a minus 1, but the sum becomes 2. Now if you go deeper, then a minus 2, this is a minus 2, and the sum becomes, if you do plus 1, now sum becomes 2. If you go to the left side, right side of this node, so now the number of edges that is now available to you for placement is a minus 2, and the sum becomes 3. And similarly here also you go to a minus 2 and the sum becomes 3, and you go to a minus 2 and the sums become, if you place 2, now the sum becomes 4. As you can see here, there is a overlapping sub problem. A minus 2 comma 3 and a minus 2 comma 3 both are present at two places. So if we calculate it here, then I will use it here also using memorizations. So here there is a sub problem overlapping sub problem, so we can use memoization. Now let's discuss the DP size that can, what is the dp size. So for first parameter a, number of edges in worst cases can be n minus 1, and the second parameter sum, the sum can also become approximately n, because every time you either add 1 or 2, so the worst case becomes 2 into n minus 1. Let's say you assign 2 every time to till n minus 1 edges, so the complexity become, so the space required for this dp table is approximately n square. So according to problem constraint, n is lesser than equal to 10 raised to the power 5. So how can you do it in O of n square space with dp? It will give you TLE. It will give us TLE. So now the question arises: how can you optimize this DP table, DP diagram, such that you get the correct answer, and you don't you don't need this O of n square complexity. And this is required for time complexity also, because time is required also will be O of n square. So this is giving me TLE or MLE also. So DP table requires O of n square space, which is not optimal. So how can you do it? Now the question I want to ask you, does it really matters? What is the sum? Or its parity is enough for us? Let's think on this question, then answer. The answer to this question is, we only we can only consider the parity of sum, which is either 0 or 1. 0 or 1. 0 denotes the sum is even, and 1 denotes the sum is odd. So let's say the updated tree diagram for this DP approach will be a of 0, and if you do plus 1 or you do plus 2, if you do plus 1 to 0, then you reach at this node, and then now the number of edges will decreases by 1. And here also, if you place plus 2 here, now reaches, you will reach at this node. Why? Because if you plus 2 here, then now the node will become a minus 1 comma 2, but the parity of this 2 is simply 0, so you can store only 0 in this place, not needed that you always store the sum, you only store the parity in the second parameter. Now in this case also, here the parity is 0, because you add plus 1 here. So if you add plus 1 and plus 1 two times, now the number becomes even, so you need only store 0, which denotes the even number which is present at this sum place. Similarly here also a minus 2, and now if you add plus 2, first you add plus 1 and then you add plus 2, now the parity becomes odd, so you will denote it with 1. So I hope you got this, how this 0 and 1 is used for even and odd, and it will simply reduces our dp table size. That is, first node is a, so the edges is n minus 1 in worst cases, and the second parameter is parity, which is of only two sides, that is 0 or 1. So the complexity of this approach is simply O of n, approximately O of n. You do the same approach here, but for some you will always modulo it by 2. Let's say here the sum is 0, so you will modulo it by 2. Now the 0 modulo 2 will be 0, so 0 is here. Now here is 1, so you will do 1 modulo 2. Now the 1 is here. Here is 2, so you do 2 modulo 2. Now the 0 is here. Here is 2, so you will do 2 modulo 2. Now the 0 is here. Here is 3, so you will do 3 modulo 2. Now the 1 is here. So according to this, you can easily place 0 or 1 in the second parameters, and now the dp size becomes only approximately O of n. So I hope you got the intuition. Now let's jump to the code. Here is my simple Java code. Let's make it white. So first of all, I initialize my mod 10 raised to the power 7 plus 1 plus 7. That is, we have to do mod with the number so that our answer will always remain in the integer range. And we initialize our n to edges dot length plus 1. That is the number of nodes. Number of nodes. And we initialize our dp of integer data type of n size and 2 column, so n rows and 2 columns. The first column is used for number of h, and the second column is used for parity, either it is odd or even. Then we change our edges array into the list of adjacency list, such that every node will contain list of some nodes x y z, which is denoting that you can reach x y z from this node. Let's say a, you can reach a to x y z any place in one step. This is denoting by this adjacency list. Now I will populate this adjacency list just like a classic example of graph traversal. I will do BFS on this adjacency list where the source is only 1, because 1 is the root node. Now I will do level wise traversal and calculate the level minus 1 and return it to my depth and store it in the depth variable, which is denoting the number of edges. Number of edges. After getting number of edges, this is not significant. I use it for debugging, but it is not significant. So I will simply return memo of depth comma 0. I will always prefer the changing parameters in this memo function, and I always define other parameters globally, like here integer of dp. I will initialize it globally, and now I will initialize. This is the BFS approach. This is the DP approach. Let's see the below code of the base case. That is, first case is odd, so you go to the edge minus 1 and simply do sum plus 1 and modulo 2. This will give you the next node, and then again even is equal to memo of edges minus 1 and sum plus 2 modulo 2. And after that you will simply add both of them, and don't forget to mod it with mod so that your answer will remain in the integer range, not overflowing it. And simply I will memorize it with dp of edge sum, and if it is already calculated, then I simply return it. Don't need to overcomplicate your solution, because you store the answer into your edges comma sum, so you will simply return that. The base case is where when the edges is equal to 0, so if you will simply return sum will either 0 or 1. So if it is 0, that means the sum will be even, so you have to return 0, so that path will be discarded. If you return sum equal to 1, that means the sum is odd, so it means that that path is considered, so you will simply return 1. I hope you got my solution and the intuition behind this question. Please hit the like and subscribe button so that I will make such kind of video regularly. Thank you for watching my video.